All right, so we are talking about the copper 2 chloride lab. We're talking about what happened. What were we looking for? So we took these graphite rods attached to a battery and we plunked them into a solution of copper 2 chloride. And we were trying to figure out which ion goes to which lead. Does it go toward the positive side or the negative side? And that can help us determine what is going on there. Is the metal going to be positive? Is the metal going to be negative? What's going on with the non-metal? So our question that we were really seeking is, in an ionic compound, can we start to predict what part becomes the cation or the anion? So let's review these terms real quick. So an ionic compound, that is a compound, so it's been chemically combined. It's a metal plus a non-metal, and they're made of cations and anions. Now the cation, that is the positively charged ion. That's the particle that has a positive charge. The anion, well, that's the negatively charged ion. That's the ion that has a negative charge. So we put both of our electrodes, or our leads rather, into this solution of blue copper chloride. And it's just floating around. It just dissolved. So we don't know what is doing what. So I don't know if the copper is positive or negative. I have no evidence yet. But I know that I have the negative electrode hanging out on this left side. I have this positive electrode hanging out on this right side. So after about 30 minutes, we see that these coppers start to hang out on this negative electrode. And these chlorines, the little bubbles of gas, etc., is over here. It's still dissolved. It has like a yellowish hue if you leave it in long enough. They start to hang out on this positive electrode. So that means we can make a guess. If we know that opposites attract, we can guess that the copper must be positive. So if it's over here on that negative electrode coming down, then it has to be positive. Because if it was negative, it would be repelling, correct? So if we're over here on the positive side and we see this yellowish hue of the water, we know that that must be the chlorine over here. So this brings us to this big conclusion here, that if we repeated this over and over and over again with different ionic compounds, metals will always become the positive cation. Nonmetals will always become the negative anion. So the metals will give up those electrons to the nonmetals. So our big takeaway, and this is the important part, metals easily lose electrons, while nonmetals will gain them. Okay. So what are metals? So we looked at it before, but let's just double check. So that's our left side of the periodic table. So the physical properties of any metal, they have luster, means they're shiny. They're good conductors. They'll take electricity and pass it from one thing to another, right? Now we know that those are electrons moving. They're ductile, meaning I can pull them into like a wire. And they're malleable. I can hammer them down into sheets. The chemical property, this is our new one. They lose electrons easily. So they become our positive ions called cations. Our nonmetals, well, those are dull and brittle. Remember the sulfur when we saw that last unit in Unit 4, the sulfur was this yellowy powder almost. They're all poor conductors, waxes, things like that. They're bad conductors. They don't do that well. And then they're brittle. They break apart nice and easily. And then the chemical properties, which is our new property, they tend to gain electrons. They become the negative ion, and we call that an anion. Now, I do want to point out over here, these are our noble gases. We have not talked about those yet, but we will later. And then lastly, we have our little staircase crew over here. It starts with boron, goes to silicon, germanium, etc. And this little staircase are our metalloids. The only thing we need to know about them is that it's a mix of metals and nonmetals. All right, that's all I got for you. Thank you very much, everybody.